A warm greetings to one and all. In this session, let's learn about function templates in C++. Topics to be covered in this session are introduction, why function templates, merits and demerits of function template, defining function templates, and finally, let's check out an example program for function template. Templates allows functions and classes to operate with generic types. So it also allows functions or class to work on many different data types without being rewritten for each one. So C++ standard library is mainly based on standard template library, that is STL. Now let's check out the types of templates. So first comes function templates. The function templates behaves like a function except that the template can have arguments of many different types. Class template. A class template provides a specification for generating classes based on parameters. Class templates are generally used to implement containers. A generic function that represents several functions which performing the same task but on different data types is called function template. If you need to perform identical operations on two or more types of data, then you can use function overloading. But better approach would be to use function templates because you can perform this task by writing less code and code is easier to maintain. For example, a function to add two integers and two floating point numbers requires two functions. One function to accept integer type and another function to accept the floating point type as parameters. Even though the functionality is same, we require two functions here. Using a function template, a single function can be used to perform both additions, which means which has two different parameters, that is integer and floating point. It avoids unnecessary repetition of code for doing same task on various data types. Why function templates are very much important, which means the templates are instantiated at compile time with the source code, so it is important. Templates are used less code than overloaded C++ functions. Then templates are type safe, that is, even though if you are using multiple types of data to perform a same function, it is type safe. Templates allow user-defined specializations. Templates allow non-type parameters. Overloaded function versus function templates. So the demerits of overloaded functions are program consumes more disk space and time consuming since the function body is replicated with different data types. The presence of error in one function needs correction in all overloaded functions. So the merits of templates are source code reusability, which in turn promotes readability, reduces the redundancy, and increases the code flexibility. A single name for function templates can represent for many data types. Now let's learn about defining the function template. So the syntax is, the first comes template, which is nothing but the keyword, followed by angular bracket. So within the angular bracket, we have to give the type name. So type name is also a keyword. It is used to declare the type of the parameter inside the template. So we can use the keyword class instead of this type name also. So it results the same. Then followed by the type name, we have template parameter. So template parameter is nothing but the placeholder for any data type which is being used in the template. So following this, we have the function declaration and definition part here. So first comes template parameter, then followed by that we have the function name. After the function name, we have the list of arguments to be used inside the function. So we can have a number of arguments. So here we have variable 1, variable 2 of template parameter type. Then we have open curly parentheses followed by statements to be executed inside the function template and ended with the closed curly parentheses. Let's have an example program using function template. So here template is a keyword and within the angular bracket we have declaration type parameter in template where type name is the keyword and T is the placeholder for any data type. So next we have function definition, where T is the template type followed by the function name, that is max, and which has a list of arguments such as x and y of template type T. Next we have open curly parenthesis, and the function max returns the value of maximum among x and y using the ternary operator. The function ends with closed curly parenthesis. Next we have main function. Here max int within angular bracket followed by list of parameters, that is 3, 7. So it is a function call to the max function template, explicitly specifying that template parameter T is of integer data type. So in function template, this specifies that function call is a version of max function template where T is replaced with integer data type. So the compiler here internally generates and adds the below code. So we can see here the template type T is all replaced with integer data type. So int is the return type of the max function and the arguments x and y are having integer data type. And it returns the maximum value among x and y using ternary operator. That is, so we have 3 and 7 as list of arguments, which is being received here. 3 greater than 7 is false. So the value of 7 is being written back to the main, and using cout statement, it is displayed to the user as shown in the output. Next, max within angular bracket, it is float, followed by the list of arguments 3.0, 7.3. So it is a function call to the max function template, explicitly that template parameter T is of type float. In function template, this specifies that the function call is to the version of max function template where T is replaced with float. So compiler internally generates and adds the below code. So here we can notice that the function template variable return type T is being converted or replaced to floating point data type. So the max function has the return type float and the arguments x and y has type float. So here among x and y using ternary operator, that is 3.0 and 7.3 is being compared since 3.0 is not greater than 7.3. So the value y is being written back, that is 7.3 is written back here, and using cout statement, the value 7.3 is displayed to the user as shown in the output. So hope you are clear in function template with this example program. Thank you all.